Stan Gibilisco here. I'm going to explain the principle of cylindrical coordinates in three-dimensional space. You start with a Cartesian xyz space. X is on the horizontal axis going left and right. Y is on the horizontal axis going at a right angle to the x-axis. And z is the axis that goes at a right angle to both the x and the y-axes. Now for cylindrical coordinates, you define the position of a point P, as in papa, according to somewhat different parameters than the x, y, and z coordinates themselves. You start at the x-axis and you measure an angle, or you determine an angle theta going counterclockwise from that axis at a radius r from the origin. And when you've made a part of a circle that has an angle of theta with respect to the x-axis and a radius of r from the origin, you arrive at a point that we'll call P prime, which lies in the xy plane. Then you go up by h units to get to your point P. So the coordinates are, in fact, theta, r, and h. And the reason they call that cylindrical coordinates is somewhat apparent if you consider that when you take this circle with radius r, or any other radius, and you extend it up, every point of it straight up, you will get a cylinder. So they call it cylindrical coordinates. Based at the same origin, theta equals 0, r equals 0, h equals 0, but then you go out by a radius r counterclockwise in the xy plane by an angle theta, and then up by a height h. Generally, the coordinates are listed in the order theta, r, h, although you might also say r, theta, h. Three coordinates, but they're defined according to different parameters. So P, point P is in papa here, has the coordinates theta, r, h. Looks like theta is probably about 140 degrees. R, if each one of these circles is 1 unit, would be 1, 2, about 3.7 units out. And h, you can't really tell here, but it looks like a little more than r, maybe 4 units up. If you just want to sort of get an idea. So you can use three coordinates just like you would in xyz space, and of course this point P, as in papa, has certain coordinates x, y, and z. So there are formulas to transform from cylindrical to Cartesian coordinates and vice versa, but I won't get into those. I just meant to show you what cylindrical coordinates are, what the variables are, and how they look geometrically. Stan Gibilisco is signing off. Until next time, so long.